Okay, so we're going to try this again. We're going to find the perpendicular bisectors of each side of this triangle. We're going to construct them so that we can find what we call a circumcenter. And what is the circumcenter? Well, the circumcenter is just a point where all of the perpendicular bisectors, there are three sides, so there should be three perpendicular bisectors, but where all three of those lines will intersect, and we call that a point of concurrency, but we'll get into more details as we go. So first, I have my tools. I have a compass, which is kind of a different kind of compass, but it's still a compass, and then a straight edge for creating straight lines, which I will need at some point. But now, when we are creating our perpendicular bisectors, we need our compass to be open to more than halfway. In prior lessons, we kind of learned that. So I'm not going to go review all those steps, but I'm going to create the arc above the line, and this is in relation to segment AB. So then I went above and below from point A, and now I'm going to go above and below from point B. And now my concern is, which is my mistake that I made last time, is that, okay, my arcs aren't perfectly lining, so I do have to extend this arc. And so now the challenge that I have to worry about is, because it's not the perfect tool, right, I could be just off a little bit. And what I mean by that is this little center, if I don't get it exactly to the center, this could be off by just a fraction. But we get the idea regardless. And the idea is really the key here. And so now I'm just going to connect those 2 points and just draw a line through those. So again, notice my line doesn't go perfectly through. And I'm going to erase it just for the point that I want to be a little more detailed. That's why I kind of draw it light, so it's not like a heavy filled in line. Because if I make a mistake, a subtle mistake, and these subtle mistakes compound over time, that create more room for error. But what I do notice is that this line right here, AB, and this line that I drew, let's call it, we'll give it a name, we'll call it line L. But line L appears perpendicular, and in fact it would be if you went and used the compass to measure it, and we can kind of do that just for the purpose of this. We will assume these things are all true, but I'm just going to show you, if I kind of find the center of it, it does line up to 90, and let's get that perfectly there, and notice that that line is perfectly perpendicular. But another benefit of doing this is that it cuts segment AB into 2 congruent pieces at this point here where it intersects segment AB. We'll call that D. So AD is congruent to BD. So we can conclude AD is congruent to BD. Those segments are true based off of this being a perpendicular bisector. So line L is a perpendicular bisector to segment AB. All right, so we're going to replicate that process 3 times. And the point behind doing it 3 times is that we'll see where all these perpendicular bisectors intersect. So I'm going to turn the paper just to kind of go through that, and the same process should be done. And it once you get a hang of it, it goes a little bit faster. But I'll put an arc above and an arc below. I could draw whole circles. I just don't want to have whole circles all over my paper, but I could do that. And again, I can run into kind of that same mistake where I don't get my my partial part of the arc up here, so I have to go back and kind of adjust a little bit. But notice it's a little bit off. And why is it a little bit off? It's because the center of my compass does not necessarily align perfectly every single time, and that's why the other compasses are useful. But these are the tools I have, and this will give you the idea. So, but now we do see this point of intersection right here of the 2 lines. We'll call this line K. Okay, and notice that this right here should be perpendicular. So line K should be perpendicular to AC if we did it correctly, and it appears to be done pretty close. Again, we can double check it. We can take our compass and kind of put it there and look at it, and it does, if I line it up and get that 90 right there, it does kind of match up with something that is perpendicular. Now, what we also notice is by the rule is these 2 sections should be congruent. So now this point right here, and we're going to call this point, we have this D, we're going to call this E, we're going to call this G. And the reason why we're calling it G is we're going to add one more perpendicular bisect, and we're going to do it to the side BC. And again, there will be a subtle margin of error in all of this, and it's simply because, well, the location of the center of my compass. Now, if you used one of those traditional compasses, you might avoid that error, but this, again, is the tool I have, and for the point of understanding the concept, it's less relevant because you will still see the effects. Okay, so now I have this point right here and this point right here where they went, and that really does look pretty good. Notice that my points are all, this looks like it wants to go through point G pretty good, which is exactly what we want, and we're going to call this F right here. And then this point right here, of course, is just on this line. And again, what we want to look at is this line perpendicular to the segment? And it is. When I match it up, notice that that is 90 degrees also. But the other thing, so we know that this is perpendicular, this is congruent to this and this. And so that what we do notice right here is that this point G, and I'm going to turn this over, it's a little upside down, but point G is what we call is the circumcenter. Circumcenter. All right, and the circumcenter, all that means is it's the point that is equidistant from A, C, and B. So when I say equidistant, if I take my compass and I open it up and I get this compass, again, I'm going to be very careful about this because it's tricky, but because my compass is not one of the best compasses, but it's a good one. If I put my pencil tip in it and I put it here, when I go around the circle, and you will kind of see that as I go around the circle, that this point is the center of the circle that goes around the triangle. Now, it didn't go through this one again, and there's a subtle reason for that, is that the margin of error of using the compass that I have that has a slight chance of error will compound over time. So all my lines and my points, there's marginal fractions, small little nuances, but this is the result. So the point of the circumcenter is to be able to draw this circle. It finds the point that is equidistant. And so what's really important here is that we kind of think about, okay, well, if it's equidistant, that means from point G, I actually can draw a radius from A to G. And I can, from C to G, I can draw a radius, right? And then from B to G, I can draw another radius. So all of these things help us with figuring out different points of the triangle, but giving us different pieces of information. And that's how you find the circumcenter. Now, granted, this is an acute triangle. It's an acute triangle, so there's some important information, the fact that it's an acute triangle, and that means that the circumcenter will be inside the triangle. I'll use a little triangle, but that concludes kind of the beginning steps of what we are going to be doing.